Hi everyone, my name is Amitesh, and in this video we're going to talk about what is a function. Right from the basics, what are functions, how do we find the domain of a function, and to give some examples of functions and really come to terms with what they are, because they are the most important things in mathematics, arguably. They come up everywhere, they're the basis of precalculus and calculus, and so we're just going to dive right into it from the basics. Even if you've seen functions before, you might benefit from this video just seeing it from this perspective, and if you haven't, it's super accessible and self-contained. Okay, so let's dive right into it. So the question is, what is a function? So I'm going to start off with the following. So we're going to talk about functions. Now, a function is a rule. Okay, so I'm going to draw a diagram. It's a rule where you have an input. Okay, your input, you can think of your input as a number, and we're going to give some examples for sure right very soon, but an input is a number. You apply your function, okay, so this is your function, and you spit out an output. So you go from your input to an output and you get your output from there. So a function is a rule that takes in an input and spits out an output, and you've seen many such functions already. No matter what stage of math education you're in, you've definitely seen these. Here's one example of such a rule. Okay, the rule I'm going to write down is going to be add 1. That's going to be my rule. Now this rule is a function because whatever input you give me, I'll give you an output by applying that rule. So for example, if your input, let's just sort of draw, if your input is going to be, let's say, 3, what's your output going to be when you apply the function add 1? Well, you're just going to add 1 to 3. So you're going to get 4. 3 plus 1 is 4. Similarly, if your input is, say, -1, what's your output going to be? Your output is going to be 0. Okay, so far straightforward. We just want to kind of understand what the function is. At its core, that's what it is. It's just such a rule. And we can draw a table. Okay, so this rule is very beautiful if you think about it, because it describes an infinite amount of data. Any number that you give me, we apply this rule, we're going to get an output. We don't have to like draw a table. Like technically speaking, we could draw a table, right? We could sort of say input, output, and suppose I wanted to make my rule adding 1, but I didn't know how to describe it. So I just sort of said, okay, I'm just going to draw a table. My input is 3, my output is 4. My input is -1, my output is 0. My input is 2, my output is 3. You can just go on forever. But instead of that table, if you just say, here's my rule add 1, you've just summarized that infinite amount of data, which is that table, all in one go. Okay, and that's the beauty of functions, that they give you a convenient way. These rules are very convenient for describing data. Okay, so we'll get into this. So that's one example of a function, which is add 1. Now, there is something called function notation. Okay, and we're going to talk about it from the context of add 1. What it is a mathematical way, symbolic way of writing down that rule add 1, which is in English. And how it works is the following. So what you do is you use the variable x. Okay, so a variable, remember that a variable x is just denoting anything from a range of possibilities. Okay, so x could be anything. X could be 4, x could be 7, x could be 9. It's just, that's what it means to be a variable. And what we do is we define our rule by saying that x is going to go with this arrow to x plus 1. Now what that means is, whatever x is, you're going to add 1 to x. And that summarizes the rule add 1. Okay? That summarizes that rule. So whatever x was, if x was 3, we're going to get 3 plus 1, which is 4. If x is -1, we're going to get -1 plus 1, which is going to be 0. Right? So that's the rule. Now, mathematicians, like over time, we develop some notation. So instead of writing out in this way, we're just going to compactify this even more and just write it out as simply our function is just x plus 1. It's understood x is the input. Our output is x plus 1. And the way people write this is they write it as f of x equals to x plus 1. What this means is that our f here, so I'm just going to put this in red, our f here is going to be our function. Our x here is going to be the input, and the x plus 1 here is going to be the output. And the way you read this equation is you say that f of x is equal to x plus 1. So f is our rule. That rule of x, so applied to x, is going to be 1 more than x. Add 1, which is what we wrote down in English here. Okay, so that's what we're going to get. And this is how we write out this function. Okay, so in this diagram, you sort of think the input is x, the function is f, and your output is going to be what we call f of x. Now let's do some examples. Okay, so I'm just going to write this out very explicitly. What does this look like with the add 1? So this table can be replaced by, instead of input and output, we can sort of say that we can work out some values. F of 3 is just what the rule does to 3. Okay, so you literally plug in. If x is 3, you're going to get 3 plus 1 on the right. So you're going to get f of 3 is 3 plus 1, which is equal to 4. Right? Similarly, f of minus 1, you literally just plug into the formula. That's the function. F of x is x plus 1. You're just going to get minus 1 plus 1 is equal to 0. All right? So these are examples of values of the function. They are values because basically they are possible outputs. Okay? So you take there's some input that gives you that output. 4 is a value, 0 is a value, 3 and negative 1 are inputs, 4 and 0 are outputs. Okay? So we've done that. That's our function. Now, the English way of writing things is the starting point, and then once we get used to that, we start writing it mathematically. That's how a lot of math is. You know, sometimes when you see a very complicated formula or equation or lots of symbols, you know, a lot of people think, okay, like mathematicians, they think about things in this weird way and it's very complicated. Maybe they're some kind of genius. But the reality is we think about things basic ways, and then as we get used to them, we write them out in a mathematical way. You know, no one really starts by thinking about it this way. We get used to it. Just like when you learn a language, you get used to it over time. You know, you don't just start off by speaking the language fluently. Okay, so it's the same thing here. So let's kind of talk about another function, and I'm going to write it out as follows. The function is going to be, the rule is going to be the following. The rule is going to be multiply by 2. Okay, so multiply by 2. That's going to be our rule. Okay, so what's our function going to be? Okay, so how are we going to describe this mathematically? So the thing is, the input is your x. What is your output going to be? If your rule is multiply by 2, what's your output going to be? Your output is going to be, if your input is x, your output, we're going to denote this function by g instead of f. So g is another commonly used letter to denote functions. We're going to say g of x. What's going to happen to x if you multiply by 2? It's going to be 2 times x. So you write this as 2x. That's our function. Okay, so you already see that we've got a nice compact way of writing our function without using any words. That's cool. We've sort of described our own language. And now we can find values. So I encourage you to sort of find out some values. What is g of negative 3? What is g of 10? Have a think about that, pause the video, and we'll get into it. So g of negative 3, just plug it in. X is negative 3. X is our variable. It has become negative 3. Then our rule, our output is going to be 2 times x. So it's going to be 2 times negative 3, which is negative 6. If x is 10, then it's going to be 2 times 10, which is 20. So g of negative 3 is negative 6, g of 10 is 20. Okay? That's all there is to it. Once you can even do that, you know, you can even think of it just in terms of the rule. If your input is negative 3, your output is multiplying by 2 is going to be negative 6. If your input is 10, your output multiplying by 2 is going to be 20. All right? So that's what we can do. So we've done that. Now we can describe more and more complicated rules. So first of all, you know, as of now, you may ask, why would I even write it out as, you know, 2x or x plus 1? Why don't I just keep it as multiply by 2? I mean, that's pretty simple, right? You don't have to use any notation. But we're going to start getting into examples where it becomes convenient to actually use this mathematical notation. So let's look at one such example, and this is kind of a quick challenge question. I want you to leave a comment down below and tell me what you think the function is going to be written as mathematically. I'm going to write it out in English first, and then you can leave a comment down below and tell me how it's written down mathematically, and then see how it works. Okay, so let's do that. So let us write the following rule. So our rule is going to be multiply by 3, then subtract 5. That's our rule. What we want to do is we want to write it out as a function. Okay, we want to write it out in this notation: something of x is something, okay, in terms of x. So I'll pause the video, think about what it should be, and then we're going to get into it. Drop a comment down below as well. I love that. All right, so let's do that. I assume we pause the video. So what's the rule going to be? So one way I like to think of it, just to start off with, is in terms of a diagram. So our rule is now 2 steps, right? We're taking our input, which is x. We call it x. It's a variable, can be anything. Take x. We first multiply by 3. What happens when you multiply x by 3? You get 3x, right? But then you're doing one more step. You're subtracting 5 from the result. So you go to 3x, then you go to what happens if you subtract 5 from 3x, right? Because you go, the first step is multiply by 3, then subtract 5. So you subtract 5 from 3x, it's going to be 3x minus 5. So our output, this is our input. Our rule was described in 2 steps. So this is what is called our output, 3x minus 5. This whole process is what is called function composition. I won't talk about it in this video. If you've seen it before, you'll know what I'm talking about, but it's 2 rules stacked on each other. Okay, that's what we call composing functions, but don't worry about that for now. So how are we going to write it out? Let's use h. H is another letter. F, G, and H, they're pretty common letters. You can use other letters too. They're a little bit less common. Let's just stick with h of x. So h of x is just going to be 3x minus 5. So already you can see it's much easier to write this, somewhat easier to write this than the rule. And if your rule is lots of things stacked together, like if you go on like multiply by 3, subtract 5, then multiply by 10, then subtract 18, etc., it's going to be much easier to write it in mathematical notation. Okay, so that's going to be the convenience of the mathematical notation, and we can find some values, right? So how would we find some values? Let's go ahead and do that. What is h of negative 2? What is h of 1? I want you to find it out and think about it, and then we're going to do it. So pause the video. All right, so h of negative 2 is going to be 3 times negative 2, negative 5. Okay, so you're literally just plugging in that h of x, the negative 2, becomes x on the right hand side. So 3 times negative 2 minus 5, which is going to be negative 6 minus 5, which is negative 11. And h of 1 is going to be 3 times 1 minus 5, which is 3 minus 5, which is going to be negative 2. Okay, so we're going to write that as 3 times 1. You plug in the x as 1 minus 5, which is going to be negative 2. Okay, so we found some values for the function. And any number, right? If I give you any number, you can find out what the output is going to be from that input. All right, so that's basically the essence of what functions are. They are these rules, and in this video I'm focusing on these numerical functions, but you can have more abstract functions. I'll do other videos on those. Now I'm going to touch on very quickly one more concept, which I'm going to do a lot more in the next video, which is what is called the domain of a function. Okay, and let's just dive right into this. So a function is a rule that takes an input and spits out an output. We understand that. Now in the real world, sometimes functions cannot take any input you like. So obviously, like one example is this kind of rule. I mean, this is kind of it's going to sound a little silly, but the input has to be a number, right? As a rule, it's not like the input can be like an apple or something. It has to be a number. So that's understood as the domain. So here we would say, any real number. This is all the numbers on the number line. I've done a video on the number line. Links of all relevant videos are down in the description below. So I encourage you to check that out. But any real number is possible. Any number you can multiply by 3 and subtract 5. That's fine. So we would say the domain is just all numbers, all real numbers in this case. Okay, so the domain is like what are the possible inputs that are allowed. Now what we can do is we can take the following function, and I'm not going to write this in words, I'm just going to write this out immediately. I'm going to call it f. So I've already used f before, but now we're on to a new example, so it's understood it's a different function. F of x is going to equal to 1 over x. Okay, so this is describing something, this is a rule, okay, this is a function, because any input, you can play around with it. If I give you an input like 2, what's the output going to be? You just put, the output is the right hand side, so it's going to be 1/2, 1 over 2. You literally just sub in x, right? There's nothing in that. 2, 1 over 2. You can keep going. You can say f of -3 as a negative number, what's it going to be? It's going to be 1 over -3, which is also -1 over 3. And you can do even something like a fraction. F of 2 over 3, it's going to be 1 over 2 over 3. So this is important, that inputs need not be whole numbers. So far I've done whole numbers. Inputs can be fractions. They don't have to be integers. They can be fractions. They can be even square root 2 can be an input. So here we have 2 over 3 is 1 over 2 over 3, and when you take a reciprocal like this, your fraction flips, so you get 3/2. So that's your output. You can even say, as I just said, f of square root 2 is going to be 1 over square root 2. And you really can't say anything more than that, because we don't know how to write square root 2. It's an irrational number. I've done a video about that as well. Links are down in the description. But just for the sake of this video, we can just leave it as that. That's the output. Okay, and you can plug into a calculator and get an idea of what it looks like if you like. All right, so these are some inputs and outputs. The question I have for you is, and this may be something you already figured out, is everything a valid input? Like here, I can multiply any number by 3 and subtract 5. So any number x, the domain of this h, can be any real number, all real numbers. What about here? Can any number be an input for f? What do you think? Leave a comment down below. I'd love to see it. And also your reason of why. Like why do you think? Or you can just say it to yourself, just why do you think that your answer is right? So we're going to talk about that. So let me erase this board. Okay, so what is the domain? So in this case, it is, I'm going to just kind of put this in red. There is one number we cannot input, okay, and that number is 0. F of 0 equals 1 over 0. This is bad. This doesn't make sense. There is no valid output here, okay? And this is an important point. 1 over 0 is not infinity. It's undefined. And so this is something I'll talk about in another video, and links will be down in the description below. Depending on when you watch this video, if it's up, you'll see it in the description. But 1 over 0 is not possible, because whatever 1 over 0 is, if you think about it, right, like an example I like is like 15 over 3 is 5. What that means is that 5 times 3 is 15, right? It's the same way of saying as 5 times 3 is 15. But 1 over 0, what could it be? Well, any number you choose times 0 is just 0. So you can never put a right hand side here to make this equation valid. So 1 over 0 is undefined. Okay, and so that means that the domain of f is all non-zero numbers. Okay, so here we could write the domain of f of the function f, the domain of a function, the domain of the function f equals all non-zero numbers. Okay, so we can write it that way. Now, one more example I'm going to do is the following function. And these are the fundamental examples. I'm introducing you to the main examples of this phenomena that come up in all, even if it's a very complicated problem. Essentially, the thing you have to keep in mind if you're trying to understand the domain, and as you get further along, you'll see those examples, just don't divide by 0. Okay, that's one of the main principles. And the other main principle is, suppose I change f to a new function. Suppose I change it to g, right? And I write it as g of x equals to the square root of x. So this is a simple enough rule. You take a number, you take its square root. That's what the function is doing. If your input, we can do any input. We can take input is 4, output is going to be square root 4, right? The rule is just x becomes square root x. So 4 becomes square root 4, which is equal to 2. Then 9 becomes square root 9, which is equal to 3, right? And you can keep going. Sometimes you may not be able to simplify, right? So if you have something like 13, well, I would just leave the answer as square root 13. We can't write, you can write that out as a decimal. It's an irrational number. The decimal never repeats, or it just doesn't terminate. So this is the best answer you can write. It's just square root 13, okay? So this one rule describes a whole array of information. That's the cool thing about functions. What is the domain of G? That's the question. What numbers can we take the square root of? And this is another important point, just like dividing by 0, it comes up a lot. Think about it and leave a comment down below if you like as to why you think it as well. I'm always open to hearing, and I can learn from you too. Everyone has different ways of thinking. Even though we ultimately write out our answer in the same way, we think about it differently, and different ways of thinking help. So maybe other people can learn from you too if you leave a comment down below. But let me answer the question now. So assuming you've paused the video and given some thought of what you think the domain of the function is, what are the possible inputs? Well, I'm going to tell you the following. What happens if you take g of a negative number? G of negative 1, square root minus 1. G of negative 3, square root minus 3. Do these make sense? And the answer is no, because there is no number that squares to be negative 1, and there is no number that squares to be negative 3. The square of a number is always going to be at least 0. You can also think about it this way. For example, if I did, the square of a negative number, right? The square of a positive number, any positive number, is going to be always positive. Square of a negative number, negative 2 squared, for example, is negative 2 times negative 2. Negative signs cancel and become positive, so that becomes 4. In general, it's true, this is a fact. If x is a real number, so x is any number you like on the number line, then x squared is always at least 0. And the idea is that a negative number, the negative signs cancel when you square it, so it becomes positive. 0 squared is 0, and a positive squared is positive. So you can never take the square root of a negative number because there is no answer. Now, if you've hypothetically seen complex numbers in I, that's a whole different kettle of fish. I won't talk about it in this video, but suffice it to say we're talking about real numbers when we're talking about these functions. So complex numbers don't come into it. So you cannot really take the square root of minus 1 and square root minus 3. They don't make sense. So we would say the domain of G is basically all numbers at least 0. Okay, so all numbers greater than or equal to 0. Okay, so I won't write it like that. I'll just say at least 0. All numbers at least 0. Another way of saying that is all non-negative numbers. Okay, so non-negative means that it cannot be negative. So 0 is allowed. 0 is a non-negative number. It's not a positive number, but you still can take the square root of it because 0 squared is 0. So the square root of 0 is 0. So you could say g of 0 is equal to 0. So these are the fundamental principles. I'm going to stop there. I've just tried to introduce you to what are functions, how to write them out mathematically, what is the domain of a function, to give you a solid background. And in future videos, links will be down in the description below. We're going to talk about more and more about this, how to find the domains of functions, what is the range of a function, what is function composition, how to study functions. This goes on and on, but it's just numerically, how do we think about these? This is the start of everything. It's just a convenient way of describing rules, to describe them mathematically. I hope you loved this video, and if you did, it would mean a lot to me if you could please like and subscribe. My goal is just to create free accessible math education worldwide to as many people as possible. I really believe that everyone should have the opportunity to be able to learn and enjoy math. A lot of math, if you read books, sometimes you have to pay for the books. I want to just make this all free. It's all on YouTube. Liking and subscribing is also free. It takes a second and means a lot to help me achieve the goal. So thank you so much, and leave a comment down below if you have any feedback, thoughts. I'd really love to hear them, and I'm super excited to engage with you. I'll do my best to reply to as many as possible, and I will really look forward to seeing you in the next video. So if you subscribe, you'll be always notified of new content. So see you in the next video, and wherever you are in the world, I wish you all the best. And whether it's morning, evening, night, whatever is going on, I always wish you the best, and I hope everything goes super well for you, and I'm super excited to see you soon. So please take care, and I will see you soon.